Hello, my name is Divyum Singhal and today I'm going to be talking about a theory which may not make sense at the first time, but it is the one which governs the laws of the quantum world. This theory states that if you know the position of an object at a time, then you cannot know its momentum certainly and vice versa. Yes, this is the Heisenberg's Uncertainty Principle. But there's one thing about it. It only works for quantum objects or objects which are very tiny. What is the reason for this? Well, it's the fact that it only works for objects which have a long wavelength. Normal objects like me and you are very heavy if you compare it with them. And thus, our wavelengths become so short that they can't even be measured in billionth of meters. And thus, the Heisenberg's uncertainty principle stops working. But for these, it does. So, how do we explain this? It's explained by Heisenberg like this. If we try to look at a particle with a microscope, then we would have to apply light on it. So if we use a very high energy light, like the violet colored lights, then we would get to know the exact position of it. But what would happen? That the electron would just end up moving away because of that high energy. So thus, we will not be able to know the momentum of it. And if we use a low energy light, like red light, then we would be easily able to measure the change in position of it. But the exact position would be unknown. Thus, the momentum would be easy to calculate, but we would not be able to know the position. And in general physics, when these are used, we do not use either red or violet, but something in between, so that we can easily get something which is certain to both position and momentum, but has little uncertainty in both of them. Another way to derive it is by Schrodinger's theory. It states that every particle behaves as both waves and as a particle. So, if we look at it in this way, then I'm going to show an animation which will help you grasp it.
In a wave, it is actually the wavelength of the wave which corresponds to the momentum. But waves are pretty much only good for measuring that momentum. The position in a wave is very unclear and has zero certainty. So in this case, we can take several waves of the same particle and add them together to get corresponding troughs and corresponding crests. These can give us some certain position and some certain momentum, but uncertainty exists in both of them. If we make this smaller and smaller, then we will finally get 100% certain position, but a completely uncertain momentum.
So, I hope that the video which I made and the animation which I made has helped you understand the Heisenberg's uncertainty principle. Thank you.